Hello. In this video, we are going to see about the process and threads. So it's the basic differences and what is actually a process and what is actually a thread. So we'll move on to the explanations part. So process. So if we take the term called process, it is actually a program which is loaded onto the memory. So, like in the terms of an NTO architecture, the process generally it is referring to a container. So to make it meaningful, so in order to make it understandable, process it is equivalent to a container. So inside container you can have multiple resources. So that is why we commonly call this process. It is going to own resources. Inside that we will be having the code, data, that is in the memory segment, and file descriptors, timers, and security context. These data are getting loaded onto the resources part. And if we move on to the thread, so thread is it is actually inside a process. So process may contain multiple threads. So what thread is actually is, it is just an execution unit. So it is the flow of control which is going to actually run the entire code. So there are certain attributes related to the execution of a thread. One is the priority. Based upon the priority, the threads will be able to get its service time, and the scheduling algorithm, the register set, and the CPU affinity. So here the condition is a process must have at least one thread to run. So if not, there is no meaning in executing a particular code or performing a particular process. So this is the basic differences between process and thread. So here it is simply given a thread which is running the code and the process which wants the resources. So if we get to know about this with a simple statement, we can very well understand what is actually a thread and what is actually a process. So visualization here, in the case of thread, that is in process, many thread will be there, as you said earlier. So which is going to share all the resources, which includes memory as well. This is fast, but it requires a very careful synchronization. If not, the current execution of the code will not be able to extract the defined output. It is not meaningful. In the case of process, it will be having its own resources. That is, we call that as an isolated one, and it is getting protected from each other. So each and every process will have its own set of resources. So they are protected from other processes. So based upon an example I'm stating here, so process I'm referring to a factory. So inside a factory will be having its own building. It will be having the power to run. It will be having the assembly line to perform certain operations. And in the case of a thread, it is equivalent to a worker who are working in the factory. So they have to do some multiple tasks based upon the time and based upon the place they are put into. So they are going to share the same resources, that is, they are going to share the same tools, but they are going to perform the corresponding operations. Here, multiple process, it is like a separate independent factories. So a worker in one factory cannot use the tool in the other factory. So it is a separate one. So what is mean by multiple thread we have seen. So why we use multiple threads? So in order to make the uh, performance of the current operating system to meet the demand, to meet the industry standard. So that is why the reason we use multiple threads, because a process must contain minimum of one thread. So if you have more number of threads, a process can do the particular activity more effectively. One is the responsiveness, that is based upon the priority. A thread can handle what is the current demanded one, what is the request it is receiving, whether low priority and high priority. So based upon that high priority task, high priority thread will be given that particular service, while a low priority thread will be updating the UI, user interface. And the parallelism, there is a term called parallelism. So this parallelism, it actually refers to a multi-core CPU where multiple threads can run at this exact time. So So that in turn will be able to cover up certain process to happen in a shorter time period. So parallelly, we are able to perform more number of threads. So efficiency is also getting improved. So since they can handle the many inputs based upon the request it is receiving without blocking the main program. So how they share the memory resources? As I said earlier, the process inside that we are having multiple threads. They are using the same memory space. That is, here it is considered to be a virtual address space. So what the things are shared? Code, the global data, and your heap. It is also shared, and shared libraries. And what is stored on its own? It is not shared to other people, other resources. It is private. Only the stack content which is being accessed only for the particular thread. Here the problem is going to be the race condition. So what is that condition? What is the problem actually? Suppose if I assume that if two threads try to change the same variable, that is the variables are getting shared by each other. So if two threads try to change the same thing at the same time, now what will happen? Let's see this example. See a thread 1, if it reads a value, it gets interrupted. That is thread 2, it is going to read the same value, changes it and save it. So during that time, the thread 1 is having low priority, so it is waiting for the task to run. So now thread 2 has completed its task. Thread 1 wakes up here and saves its old data by overwriting the thread 2's work. So now you can assume that the thread 1's data has been overwritten with the thread 2's data. Now the data is corrupted. So how to solve this issue? How to get rid of this? So the solution is simple. It is just a synchronization. We must have the control access. So that is upon performing a particular operation, we must have some kind of an access control that nobody should be able to claim that particular time slot to perform their own operation. That is, we have the process IPC called mutex, mutual exclusion. Here we are putting a lock to protect the particular shared data. So here it implies that only one thread can own the lock at a time. Suppose thread 2, if it comes and interrupts, it cannot access that lock because the lock is being performed in a time slot. So that has to wait for the time period to end. So if thread 1 completes, it will unlock that particular mutex, ensuring that data is accessed in the correct order. So this is how the critical sections are being handled in the case of this kind of problems, the synchronizations by implementing the mutual exclusion like this. The key synchronization tools is mutual exclusion, that is mutex, and the conditional variable convar. Here the conditional variable here will wait for that particular signal to indicate that I'm ready to receive or I'm ready to send. So notifications will be sent. So based on that, the corresponding process or the corresponding thread will be able to exchange data between each other. And it is said to be having an atomic operation. For example, to perform a simple task like I++ in C language. This is actually a CPU level instruction which guarantees to finish without being interrupted. So that is all about the process and thread. Thank you.